I want to talk about something for a few minutes. We just had our faculty meeting thing at lunch every Thursday. Me and the other CS people. We talked about you, by the way, Amish. Me and the other CS faculty. It was all good stuff. Most of it good. Hardly any of it was acceptable. So we were talking about. I think I've mentioned it in here before, but we're starting our CS Masters program in the spring. So our first 2 courses from the CS Masters program will be in the spring. So the first 2 courses that you have to take in there are my course, which is going to be a programming intensive course. And it's 6 credit hours, and it's going to meet for the entire semester in an evening. So 1 day a week in the evening, because it's kind of meant for non-traditional students. So it'll be an evening class for the whole semester. And then we have another class that won't really apply to you guys if you're interested in pursuing a master's here, and that's it's kind of a rehash of 490. So people who come in, it's pretty common for folks to leave undergraduate programs in other disciplines and then come and do a master's in CS. So you kind of have to bring them up to speed on CS so they can go and do it. So you guys wouldn't have to take that. Those are the 2 courses that are offered next semester. But we're looking for ways to make it less painful for our own undergraduates to transition into a master's program if you guys are interested in doing a master's here. So one thing that we would be open to doing if you did have the available credits next semester, it's one of those things where it's we don't really have the logistics for how it really should work yet. So we're kind of going to just do it and then ask for forgiveness later if we do it wrong. But basically, let's say some of you were interested in doing a master's here and wanted to kind of get a jump start, because several of you are going to be graduating in May, right? Mm-hmm. Or that's at least the plan.
Hopefully.
Okay, that's the plan. You're graduating in May. Well, you could start our master's in the spring, taking this first course. So you'd be 6 credits into the master's from this first course.
Okay.
As long as so it's a 6 credit hour course. It would probably fall underneath your tuition for your undergraduate. At least we're not going to do anything that would break that. So, since it is 6 credits, you'd only be able to take 12 credits of other classes without paying for extra credits. But that would still be cheaper probably than graduate tuition. I don't know how that actually is going to work. But bottom line is we're trying to fill the classes, and then you guys can kind of sneak in under your undergraduate tuition and get the credit, and then because we
this on recording.
I mean, we've tried to get an official policy, so we just don't know how to do it. So the punchline is that that's kind of what we're trying to do. Is if you are interested in doing a master's in computer science, which I would recommend for everybody, whether you do it here or not, I'd recommend it for everybody anyways. And it's kind of sad, but the undergraduate degree has become kind of the new high school diploma. It's just an unfortunate truth, but I think you should do a master's degree if you want to set yourself apart from other folks. At the same time, so many people in the past have told me, "Oh yeah, I'm going to go and work for a couple of years and come back and do a master's." That very, very, very rarely happens because you start making money and you don't want to give that up. Yeah.
What's the course number for that?
I have no idea.
Okay.
Five something. CSC5 something.
How many credits is the master's degree?
I want to say it's like 36 or something like that. Yeah, so it's like 6 credit hour classes.
Do you know the name of the course when I search for it?
No.
Okay.
So
it's the one I'm teaching.
If we haven't finished our undergrad yet, can we still go on with the entire master's program and kind of pair it up with our undergrad tuition for like the next year?
Let's say maybe. It depends at what point it kind of gets caught, but I would say certainly possibly. The one thing that probably won't work because you won't be able to double dip the credits. So for instance, taking the 6 credit hour graduate course isn't going to give you 6 credits of undergraduate elective credit plus 6 credits of graduate credit. So the way it'll initially work is it'll give you a jump start. So really what you're saying is would it be a year or would it be a year and a half? So would it be? Are you planning on graduating in December of 2017?
No, 2016. But if I do the math,
that's what I mean. 2016.
Yeah.
Your undergraduate, though, is what I'm saying. Your undergraduate would be done in December. So you're really talking about taking another grad class for that next semester. So kind of doing what I'm saying you guys can do for this coming spring. You want to do that maybe also in the following fall.
Yeah.
I don't want to promise anything, but I think probably. Because all this is kind of shady, potentially, anyways. And it's not even that we're trying to do it in that way. Because there's not a precedent for it, we don't really have that the flexibility to do at this point. So realistically, we could probably work something out, or at least minimize the impact on you for doing that for an extended period of time. But kind of the punchline would be, if you guys are interested in doing a master's and you'd be interested in continuing the master's here, we're starting it in the spring, and we could probably work something out where you can fit a six credit hour class into your schedule, and it'll be in the evening, so it shouldn't conflict with too many undergrad classes. I think it's on Monday nights. Is my class.
Monday nights, CSC 518.
518.
Software Design and Development.
Yep. So, that class will meet once a week for the entire semester. We'll probably meet for 3 or 4 hours each week. It's probably listed for 4, but because there's an online component, it's actually a 6 credit hour class. It's a weird thing. But in any case, I would encourage you to at least look at that. Or look at a master's somewhere, whether it's here or someplace else.
What kind of thing is the class?
That particular class is we're going to do kind of an overview of various computing technologies. So we're going to kind of do almost building an application from scratch that uses server-side stuff and uses multiple front ends and multiple different technologies. So we'll be looking at Python in there. We'll be looking at Android. We'll be looking at iOS. We might do some Xamarin, which is a cross-platform tool. So it'll be kind of like the next course after 300 in terms of programming concepts, but in the kind of in the framework of deploying applications through different avenues, different modern technologies. We might do some Node.js there. So we'll have projects, and each project will be inside of kind of different technologies, and that all might kind of work together. And we use Node.js for maybe a back end to our application, and then we have an Android front end, and maybe also an iOS front end, or things like that. Okay, so much more all-encompassing type of programming experience. But from a problem perspective, think about it as kind of data structures too. CSC 350 or something like that, even though we already have one of those. Okay. It's the course you would have 250, 300, and this would be kind of, from a programming problem perspective, the course that comes after that. So in any case, if you are interested, shoot me an email, and we can at least start the discussion and figure out what it would look like specifically for you, given how many credits you're already going to take next semester and things like that. But it is, Monday nights at 6 p.m.? Is that the time?
Yep.
So Monday night, 6 p.m., starting whatever the first week is of next semester. All right, any questions about that, dude?
Are there 2 classes every semester then to do the master's program? Could potentially finish it in a year and a half.
I would say that's correct. Yeah, typically, and like ours is kind of like a hybrid approach because it's part online, part in class. But typically, you can finish a master's in 2 years comfortably, in a year and a half if you go, you go relatively fast. And since you would be looking at starting it early, a year and a half after undergrad would be reasonable. So I think that's all a possibility. And the real problem that a lot of our undergrads run into right now, and it's unfortunate, and it's not a Concordia thing, it's a across the board thing. The bar has been lowered at the college level, so now, it used to be that college isn't for everybody. It's kind of the punchline. So it used to be that a certain percentage of the population would go to college. Other people would do like trade schools or something like that, and that's why we have electricians and stuff like that who are good at that. Well, now everybody thinks they have to go to college, and colleges like to collect people's money. So what colleges did is they lowered the bar to allow everybody and their brother to get into college and get through college. Now schools are giving what, like 4-year guaranteed programs where, oh, if you give us the money, we'll get you out in 4 years, no problem. Well, that comes with a side effect. The negative side effect to that is that now you get dumped out into the world. You're applying for jobs with a zillion other people who also got bachelor's degrees. And it's hard for employers to tell the difference between somebody who was a deserving person who should have gone to college and should have gotten a bachelor's degree and somebody else who kind of just squeaked through and took advantage of the new systems. So really, I like to say it's unfortunate, but bachelor's degrees today are kind of like the high school diploma from 20 years ago. So really, a master's degree is probably the new bachelor's degree, is maybe the unfortunate truth. So I would encourage all of you to consider a master's degree somewhere. Whether it's here or not, you got to look at financial aid and all that other crap. So there's plenty of good programs. There's plenty of top-tier schools that have all online programs. University of Illinois, Urbana-Champaign, they're a top 5 computer science school in the world. I think their master's is 100% online. So you have options. Whether you come here or not, I'd encourage you to come here because, well, not all of you, but I like some of you. But something to at least consider, to just do a master's regardless of where you go. But I'd also encourage you to stay poor for as long as you can. Because if you go out and you get a job, you say, I'm going to take a couple of years off school and then come back. I've heard a lot of people in 17 years of teaching say that, and I don't know if I can name one person that did it. Every now and then you'll have an employer who has a special program where they'll pay for a master's degree, and then somebody will come back and do like a class a semester and finish in 4 or 5 years or something like that. But most of the time, if it's on your dime, the second you start making money, what it would take to give up to go back to school, you're not willing to give up because now you have car payments and, well, more expensive car payments and a house payment and child support, whatever, things like that. Huh? That should sound pretty normal for somebody from Indiana.
Why gotta judge us like that?
It's not, facts are not being judgy.
This is true. Hey.
All right. Any other questions about that dude? If you have something specific about your situation, send me an email. We can sit down and talk, and I'll try to get any answers I can from Dr. Locklear. We just talked about it at lunch today. Basically, we're just going to work with our current students and figure out the best way to do it for each person until we kind of figure out what's the right policy. So you guys kind of maybe get a little advantage of being able to sidestep rules that aren't in place yet. Is that a thing? I think it's a thing. So, all right. So homework assignment was to add a while loop, and it sucked.
No.
All right. So let's look at this. So we decided we would have so a while loop is inside of an app expression, right?
Did we ever do recursion, by the way? I don't think we ever, we did it for homework, but we did never actually.
Oh, my code doesn't support it?
No.
Oh,
You
we didn't write it?
entire class talking about recursion
Oh.
and never actually did the homework.
Oh, okay. So do we want to do that? All right. So let's get rid of that dude. We don't need that dude. But we do need to give ourselves an expression, right?
That's up above that.
Oh, where did these guys come from? Oh, this was like when I was testing stuff, right?
Yeah.
So I can just delete like all this. All right, so the idea here, yeah, here's factorial. So if we're going to do the factorial, so this is an app expression, right? So a let takes in a app expression. So we have fact. Fact is going to get set equal to, well, fact is going to be a body of this guy, which is going to be lambda x, and then we have our if statement. Otherwise is the fact of those guys. So we're going to have a let expression here where we're going to have the local environment for this be set equal to fact. And then what we're going to do is within that, the body of that let is going to call the variable fact and apply it to 4. Okay. Actually, this guy probably almost works on his own, doesn't it? So right now, if I go do run program on this, it's going to drop in. It's going to find that we're dealing with a let expression, right? Here's my let expression. And then it's going to call eval expression. This is the body. So that guy on this guy is this right here. So it's going to call that guy. And it's going to call it on, where's my let expression right here, on the extended env, passing it list ref 2. So that's going to be the word fact. Is that what that guy is? Extend env for let. What does extend env for let take? It takes in the name value pair. Is that what that guy is? That's the name value pair. So that's going to be this guy. It's going to be fact. Well, it's going to be this. Should be that guy, right? So what that takes in? Extend env for let. Takes in what I have highlighted there, where the car of that is the variable name, and the catter of that is the value. All right, so here's extend env for let. That guy takes in a list of expressions. So we have a, it's the body of our let. So it's this guy right here. That's what gets passed into extend env for let, because that is a list containing name value pairs. Correct? That's what a let is. So that's what gets passed into extend env for let. Thing that looks like that. In our case, we only have one name value pair for this example. So we're going to be creating a new variable named fact and setting it equal to this lambda. So here's extend env for let. We're going to keep going through that guy. So as long as we're not out of stuff in the list of expressions, we'll call it extend env for, well, as soon as we're done, we'll just return the new environment. Otherwise, we'll call extend env for let on the rest of that guy on top of the extend env for lambda, the first guy with the second guy in the initial scope. So this guy should automatically do what we want it to do. I think this gives us the correct environment where we're able to store functions, because we're using extend env for lambda, this guy that already knows how to store lambdas, right? So we had taught him in a previous assignment how to store a lambda inside of the environment. All right, so for that homework assignment, we didn't actually have to do anything different here. Where am I? I'm lost. Still lost. Still lost. Still lost. Found. So this guy works as is. That piece right there. Sound right?
Yeah.
Because we wrote it in terms of the extend env for lambda, which already knows how to store name value pairs where the value is a lambda expression, which we're not evaluating. So now when we call the eval exp on the body of that guy, that means we're calling eval exp on this. That's what effectively is being sent in here. So we want to evaluate the app expression whose first value is fact, and that's going to be a var expression, right? And whose second value is for. So what do we do when we evaluate that? So here's our app expression. So we're inside our app expressions down here. So we have a couple different versions. We have op expressions. It's not one of those. It's a bool arith op expression, not one of those. If, not one of those. A let, not one of those. So it's in this else. Okay, so if we're in this else, we know the first element is going to be a lambda. And how do we get that? Well, we create a little let environment of our own. We set the lambda equal to eval expression on the first guy. So that's going to be passing it for fact. So we're going to call eval exp on the var expression associated with fact. And what is that guy going to do? That's this guy right here. He's going to apply env on fact, and it's going to return for us a lambda. Correct? So we have that lambda now. That's going to be stored inside of this variable called the lambda. So that should be our factorial function that happens to be written recursively. We haven't started applying it yet, but it happens to be written recursively. All right, so that's lambda. Then we have our inputs. In this case, we're only going to have one input. So we're going to get the 5, was it a 5 or a 4? 4 will be a lit expression. When I evaluate a lit expression, we're going to get the number 4. Right? So the inputs are going to be just the list containing the single value 4 in this case. All right, then what are we going to do? So this is the end of our let environment. So here's the body of that let right there. And what do? We evaluate the expression. What expression? The lambda given, so the lambda is going to be a lambda expression, given the environment extended with our variable name for that lambda, which in this case is going to be x, right? So we have a new variable called x, and we're setting it equal to, in this case, 4, the inputs. Okay, so that'll be the parameters coming in for that lambda. We're going to evaluate that lambda. So now when we call eval expression on a lambda, we're right here. And what do? We're going to call eval exp on the body of that lambda given the current environment. So what's the body of this lambda say? The body of this lambda says to do this. If this is true, boil down to this. Otherwise, boil down to this. All right, so let's follow that. So the body of this guy is actually going to be an if statement. So we'll eval expression on this if statement. So here is, where's my if? If expression. Okay, so we have our if expression here. So what do if we have an if expression? We eval if expression, passing it the CDDR of LCE. So let's look at what that guy looks like. I'm going to actually comment out this for a second. And we're going to define val to be parse expression and expression. So we'll get val. And then I want to get the individual pieces of this guy. So let's just print that for right now. All right, so where's my if expression? My if expression is right here. I'm going to steal that whole thing and then we'll make it a lesser piece. All right, so we're going to actually define val to be this dude. subtract x minus 1. All right, that's what val is. There we go. So val should just be the if expression now, like this. All right, so this is simulating our call into that if expression. So we'd be passing in this, so we're evaluating expression on this. So what does the if expression say to do? Says we want the CDDR of LCE. So let's see what that looks like. That's going to evaluate the Boolean expression, right? So the CDDR of val is this guy. It's a Boolean, it's an app expression that is a Boolean arithmetic op expression. All right, so this is our Boolean expression piece. It's checking to see if x is equal to 1. All right, so let's go and look how it handles Boolean arith op expressions. So here's our if expression. So we're going to go ahead and evaluate that if expression within the environment. It's going to give us, boil down to this right here. That. Oh, we wrote an eval if expression, not an eval expression. So eval if expression takes in this whole thing that has the if and the else, right? So if this bool expression is true, boil down to this. Otherwise, do this. So we have a second version here. We have an eval if expression, not a normal eval expression. Here's our eval if expression. So this guy takes in an app expression that is something that looks like this. Okay, here's our app expression, as well as the environment we're executing this thing within. It asks, well, first we say, let the Boolean expression be eval exp on the car of that app expression. So the car of this guy should be a bool expression, which he is. There's the car of it. He's a bool expression. All right. And then we are automatically evaluating the true and the false, right? That's probably our problem right now. So we only want to look at this false if this thing was true. So we really just need another let in here. So we're going to ask a question about bool expression. Before we go and just haphazardly do these other things here, we need to ask, is the bool expression true? If it's true, then go ahead and evaluate the true expression. Otherwise, evaluate the false expression. Make sense? So let's go. I'm going to steal these guys. Just going to temporarily keep these guys up here so I don't lose them. And then what we'll do is we'll go ahead and get rid of the true and the false expression here. So we're only giving us a bool expression. So that if bool expression is true, then we're going to go ahead and evaluate that guy, right? Kick this down a line. We'll do that. Otherwise, did I grab the right one?
Yeah.
Okay. Otherwise, we'll evaluate the false expression. Like that. Okay. So now what are we going to do? We're going to ask the question. So right now it's 4, correct? So is eval expression, this guy, which is our the Boolean expression, is that guy equal to 1? Is 4 equal to 1? It's not. Let's just for right now trust that our Boolean expression works, so we should get a false out of that, right? So no, it's not. So if bool expression, so if this guy is true, do this. Otherwise, what are we going to do? We're going to do this. And what does this say to do? The caddr, C-A-D-D-R, of our app expression should be this guy right here. This guy right here. This is the caddr. So that's the CADDR of that app expression. And we can prove that here. If I do CADDR of this guy, I get my current value of x multiplied by the app expression that is returned by fact being applied to 1 minus x. Make sense? So I think this should just work now, right? I think this works as is. So I should be able to now no longer do this val crap. And I should be able to just run this program. And we are running it on 4. So 4 times 3, so this should be what, 24? There's our 24. Make sense? So is that it for recursion? So we're good on recursion now?
Just out of curiosity, try a regular let expression.
Try a regular let expression?
Try to do an if expression inside of a let, just out of curiosity.
Like not a recursive thing?
Right.
Just a normal.
Just a simple little thing.
Okay. So does this do an if? We'll just modify this guy. So let's let A be equal to 5. That. And then we'll let B.
You need one more parenthesis before the A.
Oh, thank you. So it's a list of. We'll let B be if equal A 5 then do a 1 else a 2. That's the end of that. That's the end of that. And then maybe do AB. So since A is equal to 5, this will be 5 plus 1, which is 6. Otherwise, it would be plus 2. Did I write my guy wrong? I think I wrote my guy wrong. So I don't think that's broken. That's our let environment. So A is equal to 5. B is equal to the result of, is this an accurate if? Is that if written correctly?
If is 5, 1. Yeah.
Okay. That's the B. That's the let environment. Here's the body of that let plus a B. That's an expression. Just for the sake of
I
argument.
think the reason why that one doesn't work is because you throw a list of variable value pairs, and that one wouldn't be, I don't know if it would even,
You mean for the associated value with an let? So let me just try something here. Let's just do 4. So it should give us a 9. Yeah. Yes, that's the same error we just had.
That's what I was getting. That's why I asked.
Okay. Plus, so let's walk this. So we're going to do a let, and we're going to call this guy, which should create a bunch of name value pairs, right? And where did it scream?
I guess when evaluating A.
It extend env for let right here. So let's do this then. Define val to be parse exp and expression. And we'll print out val. This guy looks like this now. All right, so that guy's going to be an app expression. Specifically, he's going to be a let expression. So let's walk through there. So here's our let expression. So let expression is going to use val list ref of LCE of that guy. So that should be the body of that, which should be the plus, should be the op expression. The app expression that it contains the op expression. Let's just make sure that's the case. Yep, that's our app expression. So that's the body of that guy. That part's accurate. All right, so we are going to be evaluating this in the environment created up here. It's got to be a stupid little error we have. Nothing. He's just saying that something we did recursively broke. It's got to be our extend env for something. Let's for let. So we're just about where we need to be. Okay, so we're going to evaluate that body on the environment extended given this. So let's look at that guy now. We're calling extend env for let on that value. And this is val. Oh, one more. All right, so this is what we're giving extend env for let. Looks correct. So we're giving it an A is equal to 5 and a B is equal to 4. Okay, list of app expressions. And I think that's what our extend env for let expects. Let me get rid of the... Here's extend env for let. So it's going to take in a list of expressions like this as well as an empty environment. Oh, well, we can assume an empty environment. And it's going to go through, it's going to say, is the list empty? No. So what are we going to do? We're going to extend env for let, passing it the rest of that guy. So that'll be the second thing. And the environment from extend env for lambda, passing it the... Right, so this is going to pass it the... That should be just the name of the first element, right? That should be list of just the name. Okay, so if I paste that in there. Oh. hold on. I didn't copy it. Extend view for let. We're going to pass it this guy. So we're doing that. Where this is our list of expressions. So that should just be the A. Yep, that's our A. And then what's the other piece? So we're passing the A, and then we're passing in the this guy. And that's the guy that decides whether or not to keep it as a lambda or evaluate it. So we paste that in there. So that's this. That's that. That's that. That's that. So this should be the lit expression 5. So this guy should boil down to the list 5. Oh, I don't have a... we could just give it an empty env for right now, since it's lit. Okay, so this was the problem. All right, so it's in the value associated with the guy. Let me look at just this piece. Okay, good, that's a lit expression. That's what it should be. Let's roll back. So is a lit expression a lambda expression? It's not. So we're going to call a val expression on this guy. So let's get the rest of that here. See what that looks like. All right, so we're calling eval expression. Let me just undo stuff up here now. On this expression, in the empty environment. So that should work there. So this will work. If I copy this, we're going to get a 5. It's the fact that we have an extra guy there. So we'll get a 5 out of that. There's our 5. All right, so now the question is why is there an extra parenthesis here? What's this guy from? So here's our if. If all that crap is true, do this. Otherwise, Call eval expression. Do you know why I have this extra parenthesis there? So this will work now, but I'm guessing it'll break the other thing. That's the list 5.
What
So-
is it going to break?
Well, this will work for what he's trying to do. But my concern is that the other thing worked using the let.
You didn't actually fix it.
Oh, thank you. That'll fix it. But now I suspect it's not going to work on, I don't think I actually hit. Oh, did I fix it in the wrong place?
You never gave it an empty environment. No, wait.
I know.
It has the environment there.
Scroll back up again.
So this is how he had it written. And this guy works for, oh, wait a minute. So I want to evaluate that expression. What's the purpose of that?
Maybe you had something there and deleted it and forgot to remove parentheses.
So we're thinking these parentheses should not be there, right?
Right.
So is the issue that we didn't notice this before because we happen to be using lambdas? So we were always getting into this? That's the end of the if. That's the end of the list. So then we're extending the env for lambda in the list created. So this guy creates the value. I don't think it does though. Oh, because I had put the wrong closing parenthesis up there before.
Yeah.
And then we just fixed it. Okay. So that works for that now, but is it going to break for this? Or was that a bug that we've had all along that we just didn't test out? Yeah. Wonder how long that's been there. We spend so much time being able to store lambdas that all we did was test lambdas in our let environment. So when we made the jump from a normal let to a let rec, if you will, we never actually went back and tested normal lets. So this guy's been broken for a while. All because, what could I have possibly had there?
Isn't it down a couple?
Yeah. Was that maybe a map or something at some point?
Probably.
Yeah, it was. In the
Okay.
I'm surprised it let it run.
It didn't. We just never got to that code because we always did lambdas. Which means that was always true, so we always were executing that, which worked. All right. So I left that exercise for the reader there, and you failed me, Abe. Apology not accepted.
Whoa. Can I watch?
You haven't got the Christmas present yet.
What is this again?
When are you gonna give that to
What
him?
this
Oh, it's still on my counter. I didn't feel very well yesterday, so this morning that was all I could do to get out of bed. I still don't feel very well.
That's why Beyonce's not.
What's this?
What's not feeling well?
I don't know.
Is this something I can rub and fix?
No, probably not. I have a fever. So last night it wasn't too bad. It was like a 99.8 or something. My eyes are burning. Yesterday my stomach was killing me all day. Today that's not. My stomach doesn't really hurt. I just feel like crap. But, I mean, I don't like. It's not like death crap. It's just
Yeah,
I'm
you've had
under the
malaria,
weather, huh?
You've had malaria. So.
Yeah, it's more just slight flu symptoms or something like that. Yesterday I ended up because I had a grad class that only meets 8 times during the semester, so I ended up canceling my 210 class yesterday and went home and just slept. Got up, taught that class, and went back home and slept. So I got like 12 hours in yesterday, and I don't think that hurt.
It's because you didn't clean the mug before you initially used it.
That's what my wife said.
You got the flu from it from some Chinese person that had flu. Asian flu.
But what my grad students last night were telling me that there's something going around, some kind of Wisconsin death flu or something.
I don't know, I'm immune to that stuff.
There's always something going around, right? But they seem to all be aware of something. They brought it in. They've been releasing it slowly into the air ducts. Okay. So we're doing a while loop?
Yeah.
All right. So that guy's going to be kind of like an if statement?
We already have the word reserved in our reserved word list.
Perfect. A who? Right, yeah, he just meant up top we have a list that has the dudes in it. All right, so I basically want to steal this dude, right? And then we'll...
Don't forget to do parse as well. Parse.
Oh, thank you. Let's do that first, in fact. Man, we have so much stuff in here. Oh, you have it in there. Look at that. Oh. Oh, no, but it already works for parse.
Yeah.
Right? Parse is good?
Yeah, I just didn't have it in mind.
Yeah, I get it. I get it.
You had solved less.
All right. Let's do this. Whoa. Yeah, I always want to highlight like this and think it's all highlighted. It's totally not highlighted. It's tinted, different than highlighted. So this is a while expression. And then we probably should just go ahead and do eval while expression. Like that. And that's going to pass us the... Yeah, it should pass us everything we need. Except that, yeah, we'll just treat it differently because there's not a true expression and a false expression. There's just either a true or nothing. So let's steal this guy. And we'll define eval, while expression. And he's going to take in an app expression and an environment. So we'll go ahead and grab the Boolean expression, which should be in the same place, right? Huh?
You don't want to evaluate it.
We do want to evaluate the Boolean expression.
Well, but you have to pass it to the while statement later.
Why don't I write a while real quick? Just so I...
you have to recall eval while expression.
Eval, yeah.
Do
I don't think he could have said it better himself.
are we doing this inside of a let? Real question is, how do we get out of a while?
How? You said it equal to null.
I mean, what do you do once you're out of the while?
Yes. Yeah.
I guess I did a let expression setting I equal to whatever number.
All right.
Yeah.
Then the body.
So you basically did I is equal to 0. And that was it for the let environment. And then the
Yeah.
body of this guy was a while.
Yeah. It was a while.
One more of those guys. So this is while less than I5,
Yeah.
something like that. Do what?
I plus plus.
We don't have an I++, do we?
Or
Equal.
yeah.
I just wrote another let that was going to add. That was going to save I as whatever I currently was plus 1.
Well,
Okay.
So
But I wasn't sure how well that
you
would
just
work.
need the body. So all you have to do is put plus I1, because that's how scheme run. And that's how we evaluate. So that's the while.
But you're not.
Yeah, but that's
setting
not setting.
You're not setting it.
That's not updating this value by. Didn't we write the ability to update?
You don't update it right there. Don't you want to update it in the eval while expression? Because that's just the body of it. So that's whatever's in there.
But
So in eval while expression, what I did was I put if it was true icons. Well, that's because I had a list just saying it went through.
You created a local environment within eval while.
Yeah.
But you're assuming then that you know what's in the lambda.
Mhm.
You should write the while loops that you can put whatever you want as the body
Right.
and it would still run.
The problem with this,
If
what we
you're
don't
assuming
have,
that,
well, actually, I
you're
thought
you're
we
just
had this. Didn't we
adding
have the ability to update a variable in the environment?
We didn't really update it. We more like added an amendment to it afterwards, so that we would run into the new version of the variable before we hit the old version.
Yeah. So I just added the new scope onto it each time it went through it, updating that value of whatever the body was.
Yeah, but we can't write that code here unless we have the ability to.
Well, you can evaluate. It'll evaluate it to the new value.
Yeah,
Oh yeah, I know what you're saying.
yeah. But
Because this is an
we
infinite
have
loop.
no reason to
As I have this written
change
right
the
here,
environment from that.
I mean, well, this we could write this easily. I mean, so putting to fulfill the homework assignment, I guess, is easy enough. It's completely impractical
Yeah.
because
So-
you don't have a while loop that can do while loopy things. What does this say? This basically says every while loop you ever write is an infinite loop,
What I did,
or doesn't run even once. It either runs forever or doesn't run at all.
was the body. Basically what you're doing is you're trying to say that I is equal to whatever it currently is plus 1. So you just I was just making a let.
Yeah,
that
so you forced it by creating a let that created a more local copy of I.
Yeah, because that's how we're doing.
I get it.
That's how we're updating
Yeah.
values right
So, but the real, and that's fine. So that's just taking advantage of how our environment works.
Yeah.
So let's write the bad version of this first, because that's kind of what I guess the homework assignment was, where as long as this is true, this guy's going to print out I plus 1. Although in our little world here, without, let's call it let hacking, I never changes. Right? I never changes. So really our language is weak right now in that we can create variables through a let, but we cannot update a variable in our language. Ideally, we'd like to update the most local scope of a variable to be a new value. That make sense? Can't do that right now. So if this was true the first time, this will be true forever. Because I don't get a chance to change the value of I. Without adding that ability to your language. So where I guess you could have done that. I don't think it's going to be that hard to update a value in the I don't think it's going to be that hard to update a value in our environment, but when I gave the assignment, that wasn't my intention. But you actually have to do two things. you have to have the ability to update a variable in the environment. You also now have to have a syntax for like a block of expressions that you want to happen in a certain order. So maybe we want to display I and then update I to be 1 greater than it used to be, something like that. So evaluating that body actually means evaluating the body of a block expression in order. Evaluate this guy, then this guy, then this guy. So in that case, we'd have 2 guys. So this is what we'll ideally want to have. Let me just write a second expression here. Let me finish that guy. This is what we want to be able to write. We want to be able to write that. So teach our parser how to handle a block expression, where a block expression is a collection of expressions. So this says evaluate I, boil down to the current value of I, and then, let's make this a set I to that. Like that. That's what we really want to do.
So when you're saying block
Or
I,
if you
that
could say
first
that.
I will be just
This is a curly brace. In Java, that's a curly brace.
Yeah.
Yeah, we're going to create a block structure. So block system.out.println I, then I equals I plus 1. That's what we really want, how we really want it to work. All right, so what we can do for right now, since we don't have that, there's 2 pieces to this we don't currently have. We don't know how to create a block. Where evaluating a block expression just says, keep evaluating expressions within a block in order until you're out of expressions. Okay, and then we don't have the ability to do a set, which updates the current environment with a new value. So all we know how to do is either run a while loop forever or not run it at all. That's what we can currently do. All right, so if this is true, keep doing this. That's it. All right, so eval, so that'll be true, right? I is 0, is 0 less than 5? Yep. Off to the races. Go. All right, so if the Boolean expression is true, what are we going to do? We're going to just call the eval expression on the, is that going to give us the body? I think that gives us the body. Yeah, that'll give us the body. So if that's true, do that. But we actually want to execute it. Because ultimately we're going to call eval while expression again. On this dude, because this dude's not going to boil down to an app expression. So in our example right now, that should give us a 5, right? No, a 0.
A 1.
Oh, yeah, a 1 forever, since we're adding 1 to it.
Yeah.
So this should boil down to a 1. So that's fine. So we'll boil down to a 1 here, but then what are we doing? After we boil down to the 1, then we're calling the while loop again. We should call the eval while loop again and do something else. But the problem is that when I boil down to that 1, I need to do 2 things here. I can create a list of those, I guess, to kind of show us what the. This is kind of the, I guess, the ghetto version, but we're never gonna finish. Do we have like a global counter that just says once we hit 7, stop?
I wish I could be like that. Never finish.
All right, so eval expression, this guy, and then I guess we just call eval while expression, passing it, the app expression, and the exact same environment. You know, we could say that maybe later on we would evaluate the body and it would ultimately return for us a new environment.
Yeah, that's what I did for this.
Well, right, because you created a local environment inside of your while expression, which is fine. I get it. You had to hack it because the assignment was unclear. Well, the assignment wasn't unclear. The assignment was impractical. So
Then else. Would you just?
the else we're just done.
But you
But we're never getting in there.
You need something down there, though.
Yeah, no, I get it. So else we can
You
just
put null down there.
we can just do false, I guess. Better save because I'm afraid this is gonna crash. Dr. Racket. Gonna run out of stack space.
You just stop it before it goes too long.
Does it? Will it actually show us the output though?
No, I mean,
Nope.
We'll go back up to it. The list. So you have to cons the list onto the other one. Well, that's what you would have to do if you wanted it to continue, right? Because
Well, there's just gonna be a list inside of a list inside of a list. And I mean, it doesn't matter. It's impractical either
It's still
either
never
way.
going to print. It also, for whatever reason, at least
well, it should
when I was writing it, it was running. If I removed, list, if I just had them both inside of parentheses, it was still running anyway. I'm not sure why it was because it didn't make any sense, but it was.
Yeah, I mean, we could do this inside of a. Oy. Would save this and run it. Just, I mean,
It's just running.
yeah, I mean, it's doing what it's supposed to do. Do we ever get to see what the?
Because
Well, so there you go.
homework done.
Homework done. If you want it to finish, do you make it false the first time? We have a while loop. So, having said that, we really need to add 2 abilities to our language. One for a block and one for a set. Where a block is going to be a list of things that should happen, this guy. And the other one for a set where we can change the value of the guy before that. That make sense? All right, I'll put that up for your next homework assignment. If you attempted this one, I'll just give you full credit for this assignment. I get how it was confusing. Well, it was actually quite ezy
Yeah.
to do an impractical while loop.
Yeah.
But so for those of you who took it to the next step, who spent a lot of time on it, if you'd like, what I'll do is I'll look at the assignment. Everybody will get full credit. Some of you will get extra credit for taking the extra steps to do
To make it somewhat
the
practical.
to turning it into practical. But if you turned it in, you'll get at least 100 on it. But the next assignment, we should be able to make it completely practical with the block expression and the set.
So is the next assignment due on Tuesday? You'll post the assignment online.
I'm gonna post it right now.
So I don't remember what else is on that hard drive besides that stuff. So I mean, I really don't care. You can look through it or whatever, but just don't tell anyone else what you find.
what I'm getting
Oh,
at.
with this?
With the hard drive, yeah.
Oh, I'm just looking at your random number generator. I thought.